Scientific notation is a quick way to write very large or very small numbers. We can use powers of 10 to create short versions of long numbers. So we have standard notation, which is normally the way that you see a number, like the number 6 million, right? Very large number. That would be in standard notation. We can also write this in scientific notation. We would say 6 times 10 to the sixth. Now, in scientific notation, we do use the x for multiplication. That is acceptable. Here are the rules for scientific notation. Number one, we have a base number that is greater than or equal to 1 and less than 10. So the number has to be between 1 and 10. It can be 1, it can't be 10. So it has to be between 1 and 10, which is basically saying that there's only one digit that is allowed in front of the decimal in scientific notation. And you're going to multiply that base number by some power of 10. So for example, here would be a number in scientific notation. We would say 2.3 times 10 to the fifth. Okay, let's look at these powers of 10. Here are these purple numbers. These are, we would say, positive powers of 10. 10 to the first power is 10. 10 squared is 100. 10 to the third is 1,000. And so on. And so look for a pattern here. What is the pattern when the exponent is positive on a power of 10? Well, maybe you saw that when the exponent is positive, that positive exponent is telling you how many zeros are after the 1. Like 10 to the first power, there's 1 0 after the 1. 10 squared, there's 2 zeros after the 1. 10 to the third power, there are 3 zeros after the 1. And so on. That pattern would continue. Let's look here at the green numbers. So these are negative exponents. And so as you can see, all of these numbers are less than 1. We have 10 to the negative 1, that's 0.1 or 1/10. 10 to the negative 2, that's 1/100th. 10 to the negative 3, 0.001, 1/1000th. 10 to the negative 4, 0.001, and so on. So what pattern do you see with the negative exponents? Well, maybe you see that when the exponent is negative, we would have one less zero after the decimal than whatever the exponent is, ignoring the sign. So basically we're saying, say, if we have 10 to the negative 2, 2 is our exponent if I ignore the sign, and so I'm going to have one less zero than 2 after the decimal, and 1 less than 2 would be 1, so I got 1 0 after the decimal. If I have 10 to the negative 3, I would have 2 zeros after the decimal. 10 to the negative 4, I would have 3 zeros after the decimal. 10 to the negative 5, I would have 4 zeros after the decimal. And your last number would be 1. Let's look at a few examples here. So we want to write these numbers in scientific notation. So this number is 1,000. So how many zeros do you see after the 1? I see 1, 2, 3. So I could say I have my base number is 10 to the 1, 2 to the third power. 10 to the third power would be equal to this number, 1,000. What about example B? We have 1, 2, 3, 4, 5 zeros after the 1. So I could say I have my base number 10, exponent 5. 10 to the fifth power would be this number, 100,000. Now in C and D, these are 1 over 10 to the sixth and 1 over 10 to the 1. So we could use our negative exponent rule and say 1 over 10 to the 6, I know this is the same as 10 to the negative 6, right? Because of my negative rule with the negative exponent rule. 1 over 10 to the 1, this is the same thing as 10 to the negative 1, right? The negative rule says I would take the reciprocal, and once the exponent goes from the top to the bottom, it changes signs. Okay, now let's go with powers of 10 to standard notation. So A, B, and C here, these are all powers of 10, and I want to write them in standard notation. So I have 10 to the 7th. That means I'm going to have a 1 with how many zeros after it? This many. So 1, 2, 3, 4, 5, 6, 7, and then you can figure out where your commas go from there, right? 1, 2, 3, 1, 2, 3. So 10 million. 10 to the negative 9, okay? This is going to be, I'm going to have, if it's 10 to the negative 9, I would have 8 zeros after the decimal. So my decimal is going to be 0. Then I have 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And my last digit would be a 1. 10 to the negative 7, I'm going to have how many digits after the 0? 1 less than 7, that would be 6. So I have 0 point, then I have 6 zeros. 1, 2, 3, 4, 5, 6. Last digit is a 1. Now, here are the rules from going from standard notation to scientific notation. So we can take any number in standard notation to scientific notation. On your paper there, you see we have 3 steps. Put it, rewrite it, caret to decimal. So put it. Put it means we're going to put the caret with the decimal after the first digit that is not 0, going from left to right on the number. So at the very bottom of your page, I want you to write EX1, example number 1, and write 45,200. And we're going to take that number, which is in standard notation, and we're going to take it from standard to scientific following these 3 steps. So first, put it. We're going to put the caret with the decimal after the first digit that is not 0. So let's start here and go from left to right. Well, what's the first digit that's not 0? Well, that would be the 4. So we're going to put our caret with the decimal right there after that 4, since it's the first digit that I see that is not 0. Okay, that's step 1. I put it. Step 2, rewrite it. So I'm going to rewrite the number with a new location of the decimal times the power of 10. So I have 4, then my new decimal is right there, then I have 5, 2. Okay, like it says on my paper, these zeros at the end of the number, they would fall off because they are not needed. So I have rewritten it times a power of 10, and we're going to figure out what our exponent is in step 3. Step 3 is caret to decimal. Think C to D, like in alphabetical order. You would go C and then D. C is for caret, D is for decimal. So we're going to count how many spaces it is from the caret right here that we made, from the caret to the original location of the decimal. So in the number 45,200, I would know, of course, the decimal is right there at the end of the number because the decimal was not written in, so it's understood to be after the last digit that you do see. So I'm going to go from the caret to the decimal, and I'm traveling this way, right? I'm traveling to the right, and so I know my exponent will be positive because I'm going right. So I'm here, this is the caret, I'm going to the original decimal. So I go 1, 2, 3, 4 spaces. I went 4 spaces to the right, so my exponent on the power of 10 is positive 4. So this number right here, 4.52 times 10 to the 4th, would be the number in scientific notation. Okay, at the bottom of the page again, write EX2. This is example 2. And here we're going to get a number in scientific notation with a negative exponent. So here's my number, 0.0013, and we're going to follow these 3 steps. We'll put it, rewrite it, and caret to decimal. First off, put it. Put the caret with the decimal after the first digit that's not 0. So let's read the number from the left to the right. The first digit that's not 0. This is 0, this is 0, this is 0. Oh, here's a digit that's not 0. I'm going to put the caret with the decimal right there after the 1. So there's the caret after the decimal. Next, let's rewrite it. So all of these zeros, I would say, fall off. The decimal now is 1.3. 1.3. I'm going to multiply this by a power of 10. I got to figure out what my exponent is by thinking C to D, caret to decimal. So here's my caret right here. I'm going to go caret to the decimal, caret to this original decimal. And to do that, I'm going to travel left. And so I know my exponent will be negative on the power of 10. So from the caret to the decimal, I go left 1, 2, 3 spaces. I went left 3, so my exponent is negative 3. 1.3 times 10 to the negative 3. Circle that. So we have our steps here from standard notation to scientific notation. The last thing we'll talk about is going from scientific to standard. Now here, if the exponent is positive, that tells us to go right on the number. So if we have this number 4.96, which is in scientific notation, and I want to go to standard notation, I would put my pencil where the decimal is, which is right there between the 4 and the 9. And since the exponent is positive 7, I'm going to go right. I'm going to go right that many spaces. So here is my decimal. I'm going to go right 1, 2, 3, 4, 5, 6, 7. And here would be my new decimal. Okay, so then I could rewrite the number. I would have 496, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. This 0 I would say falls off. It's not needed because if you put 0.0, it's not going to change the value of it. So now I can figure out where my commas go. Every third digit, comma, comma, right? 49,600,000. This would be the number in standard notation. So I went from scientific to standard. Okay, one more. When the exponent is negative, I would go left. So if it's positive, I go right with the decimal. If it's negative, I go left. That many spaces. So 7.98 times 10 to the negative 6. Here's my number, 7.98. I'm going to go left 6 spaces. So I'm going to have to add some placeholder zeros here in this number. Let's add some placeholder zeros so that I can see myself. Going left with the decimal. So the decimal is here. I'm going to go left 6 spaces. 1, 2, 3, 4, 5, and 6. There's my new decimal location. So if I rewrite this number, I'm going to have 0.0, 0.1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros. And then a 798. 798. So as you can see, very small number. So I went from scientific to standard notation.